Everyone, so today we will solve the model building part of mock OPP 1. So I downloaded the data. We can see that we have 14 columns and the data is already pre-processed. Let's start with our task. Split the dataset into trained dataset and test dataset in the following manner. Use train test split to split the dataset into trained and test dataset, and the test size equal to 30%. Random state is 42 and other parameters have default values. So column except the last column should be the feature matrix. Last column will be the label vector. We just removed the last column here. Label vector contain only the last column. Now from sklearn.model selection, we imported the train test split. We defined the parameter as given in the question. Next task is to train the model on training data with the following parameters. Alpha, solver, and tolerance, and random state is given to us. So with sklearn.linear model, we will import rich and we will set the following parameters as given in the question. Now we will fit x train and y train. Enter the value of R2 score on the test dataset. We will calculate R2 score. From sklearn.metrics, import R2 score, y test, and here we will write the predicted value we have, regress reg.predict, the next test, round off up to two decimal places. We got our output as 0.66. This is the index of most important feature. Note that the index starts from 0. So we want to find the index of most important feature. So we will find the coefficient first of the ridge regressor. So coef is the weight assigned to each feature, and if you want to find the most important feature, we just have to look at the magnitude. So we will just work with magnitude, and we will use np.argmax to find the feature with maximum coefficient and its index. So we got the index as 9. So here I created a series where we have written the index and their coefficient, absolute value of the coefficient in the descending order. So maximum importance, then this has the least importance. What is the index of least importance feature? Least important feature. So we will just use np.argmin instead of np.argmax, and we get answer as 0. So here also we can see the answer, least important feature. Next question is, take SGD regressor with random state 42 estimator with grid search CV, hyperparameter tuning to be done over the following parameters. So penalty, alpha, tolerance, cross validation is 5, and scoring is negative mean absolute error. Use the best model from above hyperparameter tuning process to answer the following question. So from sklearn.linear model, we will import SGD regressor. Then from model selection, grid search CV. Inside the grid search CV, we will set estimator as SGD regressor, random state 42, and inside the parameter grid, penalty L1 and L2, then alpha, this values, tolerance, and cross validation is 5, scoring is negative mean absolute error. Now we will fit this into the training data, and we got this as best estimator. Alpha is 0.001, random state 42, and tolerance 0.0001. So now we will look at the best parameter. We got this. So question is, what is the best penalty? So we can see the best penalty is L2 penalty here. What will be the value of mean absolute error on the test dataset? From sklearn.metrics, we will import everything inside. While we will solve for OPP, I have noticed that from metrics we have to import a lot of things. So we can import everything from this metrics module using this star. So this will import everything, and we can just use this. So we will use mean absolute error, or we can just import mean absolute error here, and we got the answer 3.81. Now create a pipeline of PCA as a transformer and lasso as an estimator. Use grid search CV. We have to use grid search CV, and these are the things given. And component for PCA 0.9, and an alpha value for lasso. Scoring is same. Cross validation is 5, and jobs is -1, -1. It helps in using all the computational power to run this job. So we will import pipeline first, then from sklearn.decomposition we will import PCA. linear model, we will import lasso. Then we will create a pipeline. So this gives us the step name, and this is the estimator we have, lasso, and then we imported lasso. Now what we will do, we will set a grid search CV estimator as this pipeline. Now this here comes the little important part. If we have two estimators here in the pipeline, PCA and lasso. So how will this grid search CV parameter will know which parameter grid this n component and alpha belongs to? So what we will do is we will just write here like this, PCA, and then double underscore and the name of the parameter we have. So we will give like that, lasso double underscore and the name of the parameter alpha. So estimator, so which name we have to give here, lasso, which the step name we have selected in the PCA here. So we will just specify the name of the step and the parameter we have to specify. Now CV scoring and jobs as specified in question. So we just fit in the training data set. We got our best parameters. Now if we fit the pipeline on training data set, what will be the R2 score on the test data set? So we will just calculate the R2 score here. Grid2 dot predict on next test, and we got the R2 0.625. How much variance is explained? In PCA, variance means eigenvalue by the first principal component. So what we will do is from that grid search CV, we will first pick the best estimator. We will see that the best estimator, we will get the pipeline using this. We can access the pipeline using this, and then inside the pipeline we will take the step part by using named step, and we will specify the name of the step here which we want to specify. So this PCA part, okay, if we will print the PCA part, we will get the PCA and all the parameter inside that. So we need the first eigenvalue, okay, first variance we can say. Now what we will do, from the PCA part we will take explained variance, and this explained variance is an array, and we need the first one, so we need this one here. So we will just write 0 to get the first from the array. So we got, this is our answer after rounding off, 1.16. Create a pipeline of polynomial feature as a transformer and lasso as an estimator with the following parameters. So for polynomial features we have this parameters, for lasso we have this parameters, and we have to create a pipeline and we have to find the R2 score of that. So we will create a pipeline, poly, step name is poly and step name is lasso. So polynomial feature, interaction only is false, then degree is 2. For lasso, alpha is 1, warm state is true, and random state is 0. We will just fit it inside the training data. Now we will calculate the R2 score, Y test, and P2, which is pipeline 2 dot predict, and inside the text test. So we will get our answer 0.158. Question 9 is, if you eliminate one feature with recursive feature elimination, that is RFE, which feature will be eliminated? So we have to provide the index of the feature which will be eliminated, and we are going to use linear regression model with default parameter as an estimator. So in the X train we have 14 columns. We have to remove one column. From feature selection, sklearn.feature selection, we will import RFE, and from sklearn.linear model we will import linear regression. We will create a variable RFE, and inside that we will write this RFE class. Inside that RFE class and estimator as linear regression, and in the RFE we have one parameter called as n feature to select. We don't have n features to eliminate, so we have n features to select. So we will select 13 features and we will eliminate one feature. How I decided that we have to select 13 features? we have total of 14 feature, we have to eliminate one feature, so we will write here 13. Or we can do what we can do is x train dot shape, and we can just fetch this one by using here 1. I will get -1. I will do that here. X, okay, let's try it. So we will copy this and print and -1, so it will work same. Yeah, it will also give the same result, or you can write manually or by doing this. Now what they asked is the index of eliminated feature. Doing rfe dot support then dash, this is an attribute, it will give us true if the feature is present and false if the feature is deleted. So we can see that we got one false, means this feature is not present here. Now if we want to find at which index this feature is not present, so what we will do, list ref dot support, we will create list of this array, and then we will use dot index false, so it will provide us the index where false is present. So we got the answer is 2. And these are the few extra questions. I'm not sure with the answers, but the questions are really good. Okay, take decision tree regressor, criterion is absolute error and random state is 42 with grid search CV hyperparameter tuning. We are given with the parameters here: max depth, min sample split, max features, cross validation is 5, scoring is negative mean absolute error, and n jobs is -1. So what is the best max depth? So we have to perform the grid search CV and find the max depth. What is the max depth? Max depth is how deep the decision tree goes. Okay, so this is max depth we have. From sklearn.tree, we will import decision tree regressor, and then we will write grid search CV here with estimator as decision tree regressor, criterion and random state is given to us. Min sample split. Min sample split, it decide the minimum sample splits in the tree. Then we have max feature. Decision tree every time doesn't deal with all the features, it just chooses some of the features, or so it is decided by how many features are being chosen. Or we will take square root of number of features, or we will do log 2 with of number of features. So this is max features, how we are going to decide the number of features in the decision to regressor. Then CV scoring and n jobs is same. Now we will fit it on the training data, best parameters, and we have to find the best max depth, and we can see the best max depth is none, means there is no limitation on how deep the tree will go. Using the best estimator, find the R2 score on the test data. So we had grade 4 dot predict x test, so this will give us y predict, and we are just calculating R2 score, and we are just calculating R2 score, we got 0.78. What is the height of best tree? So to get the height, we can use the attribute dot get depth. This is a decision tree attribute. So what we will do is we will fetch the best tree first. Okay, best tree, let me try to print the best tree first. Okay, best tree. So you can see the best tree is a decision tree, and if we will do the best tree dot and control space, we will get so many attributes here. We can just use any what we want. So max feature, it will print the max feature. So similarly we get the depth. We will get the height of the best tree using dot get depth, and which is 32. So before that you have to do grid 4, that is our grid set CV dot best parameters to select the tree, and then only you have to use dot get depth. How many nodes are there in the best tree? So we will use best tree dot tree dash. So this has also so many attributes. So we will use then node count to get all the nodes. So we have around 2541 nodes. Now if we want leaf nodes, we can use get n leaves. We have 1271 leaf nodes. What is the absolute error or impurity at the root node? So if we will see at this gives us impurity of each node, and we want impurity at the root node. If we will look at this, the length of this, it is same as the number of nodes we have. So each node, each is, this is the impurity of the first node, then second node, and so on. We want the impurity of first node, that is root node. Okay, so what we will do, we'll just take the impurity of first node here. Next question is train the support vector regressor on the training data with the following parameters. So we have to use, we have to train SVR in this case. The parameters are kernel, degree, and C. What is the root mean square error on the test data set? So first we will from sklearn.svm, we are going to import support vector regressor, that is SVR. Then we are going to set the parameters training on the fitting on the train data set. Now we are going to calculate the root mean square error. We are using asterisk here from sklearn.metrics import asterisk. This is going to import everything from the metrics. Now we got our answer is 5.763. How many support vectors are there? So we will use SVR support vector underscore vectors underscore attribute, and when we will get the length of support 2720 support vectors. Tune the parameter using grid search CV for below settings. So estimator is k neighbor regressor, scoring is negative, mean squared error, CV is 5, and neighbor metric is min cox k, and p value is 2. P value is 2, that means we have to use Euclidean distance, and when p value is 1, that means we have to use Manhattan actually. Yeah. So keep the other parameters default value. What is the best k you obtained using the above instruction? So what is k? K is the number of neighbors in the k neighbor regressor. So we will import k neighbor regressor from sklearn.neighbors, and now we are going to use grid 5. This is the 5th grid search CV we are using in this. Okay, grid 5. So estimator is k neighbor regressor, parameter grid contain all these things, neighbor and neighbors metric and p value, CV cross validation scoring. Now we will fit it in training data, and best parameters are matrices. Yeah, they will be same because only one value was there, and neighbor is 11, so best is 11. Actually, I'm not sure about the answers. If any of you solve this, please let me know the answers are correct or not. Train with random search CV, so we will use randomized search CV. Keep below settings as for random forest regressor, random state 42, and all these parameters. In the random search CV, we have to keep all these parameters. Let's go. So from scipy.stats import uniform. Why we are importing uniform? Because here we are using uniform lock and scale. So min impurity decrease, we are using uniform here, so we have to import this. So I imported here scipy.stats import uniform. From sklearn.linear selection, we will import randomized search CV, and from ensemble, we will import random forest regressor. Estimator is inside the randomized search CV. Estimator is random forest regressor, and parameter distribution is this. Verbose is 2, means we need the verbose. What does verbose do? It just what output we want, how much detailed output we want. So fitting threefold for 5 candidates, totaling 15 fits. So this output is given by verbose. Okay, what was the question? Best parameter using okay, best parameter value for n estimators. So we need an estimator value which is 89. Now we will train at the post regressor with all these things, random straight and estimators and loss using impurity based feature importance. What is the highest feature importance score? What is the highest feature importance score? So we will import ADA boost regressor from ensembles, sklearn.ensembles, and inside the ADA boost regressor we can see that if we are not providing them estimator, they defaultly take decision tree regressor as the base estimator with initialized max depth 3. Okay, so now whatever okay, so we are going to use here estimator is none, that means they are using decision tree regressor here. Okay, now we are going to fit in training data and we want to calculate the highest feature importance. So we will use adb dot feature importance. This feature importance is from the decision tree regressor. Now to get the highest we will just write max here, and we got it 0.38. Now question number 11 is train bagging regressor with an estimator max feature, an estimators as 100 max features, then out of bag score is true. So random state is 42. So we have to calculate the out of bag score here. What is out of bag score? Out of bag score is related to the out of bag samples. Out of bag samples means the samples which we are not using at that particular case. Okay, the samples which are not being used, that's why they are called as out of bag. So we are using that. Now let's set bagging regressor. We already imported it from the ensembles. Then an estimator is 100, max feature is 0.7, OBB out of bag score is true, and estimators is 100. If we have to calculate the out of bag score, we just have to write dot OBB underscore score underscore. So yeah, OBB score. So it will give us the out of bag score, and which is 0.903. Question number 12 and 13 is train a MLP regressor. MLP means multi-layer perceptron regressor. It has three layers: input layer, hidden layer, and output layer. So random state is 42, hidden layer size is 20 and 20, and solver is SGD model. Tune the above parameter using grid search CV. Activation functions are given to us: logistic, 10H, and RALU. Learning rate in it is 0.001, 0.01, and 0.1. Okay, we will from sklearn what is the number of iterations the solver has run from for the best model. Okay, number of iterations we have to find. From sklearn.neural networks, we will import multi-layer perceptron regressor. Parameter as specified in the question. Grid search CV estimator is this ML. Parameter grid is activation learning rate in it. Fitting in training data. Stochastic optimizer maximum iteration reached 200. So we got our answer. Maximum iteration is 200. Okay. So dot best estimator, we will take the best estimator, then an iterer, which is going to give us the iteration which is 200. What is the bias at the output layer for the best model? Bias means intercept. When we will write best dot intercept, we will get this three array. Each array belongs to each layer. So we have first input layer, hidden layer, and output layer. And in the question we are asked to find the output layer. So this is the answer we got.